Hello and welcome to the LMI webinar series. My name is Aaron, and today we are covering PLC 101, an introduction to PLC communication. I have with me today Michael Fisher, our application engineer team lead, and Trevor Daly, our application engineer. Two very smart people who will be delving into this. And before I hand it over to them, just letting you know, if you have any questions today, please use the chat function on the right-hand side of your screen. Just pop those in, and we will do our best to answer all the questions we have during we have some Q&A at the end. And also, this is being recorded, so if you missed anything, don't worry. You'll be able to see this. This will hit your email box in a couple hours. So, without further ado, I'd like to hand it over to Michael.
Great, thanks, Aaron. All right, welcome everyone to today's webinar on PLC communication with your LMI machine vision system. Here's our agenda for today. We'll hopefully convince you of the importance of communication with your machine vision system. LMI is a 3D machine vision company. We focus on inspection and measurement using structured light. And any machine vision application, it needs a good scan, it needs good tools, but then generally the last portion of a machine vision application is communicating those results to some external piece of equipment, some external device. And in our case, usually that's a programmable logic controller, a PLC. So what we're going to show you today is how that's done with a Gocator, one of LMI's machine vision systems, and two types of PLCs out there, an Allen-Bradley PLC and a Siemens PLC, using two different communication protocols. And if you've seen our other webinars, you'll know that LMI does some amazing things with 3D machine vision. We generate very high quality scans. We integrate with robots. We can set up multi-sensor layouts. So today's demos, I should apologize in advance, are not that flashy, but what we're going to do is just as critical to your machine vision application as getting a good scan or applying the right tools. What we're going to show in our demos, both with Allen-Bradley PLCs and Ethernet IP and Siemens and Profinet, we're going to show starting and stopping a sensor, receiving measurement data from the machine vision system into the PLC, and then changing a job file as well. And we'll wrap it up with some questions from our audience at the end. So the PLC market is quite varied around the world. Where I'm located in North America, Allen-Bradley dominates. So most of the machine vision installations that we deploy here communicate with an Allen-Bradley PLC. The story is very different elsewhere in the world. In Europe, Siemens dominates, so most of their installations use Profinet to communicate to a Siemens PLC, and the story is different in Asia as well. What we're going to focus on today is communication with Allen-Bradley PLCs and Siemens PLCs, which again account for most of the PLCs that we interface with in North America and Europe. So I'll start by doing the EIP portion, and Trevor is going to do the Profinet portion. With Ethernet IP, it's a communication protocol for communicating with Allen-Bradley PLCs. Generally, the way that you use a machine vision system with a PLC is the PLC will control the vision system. So you'll send commands like start your alignment, or start taking scans, or change your job because we have a new part that we're inspecting. Those commands will come from the PLC, and then what the PLC receives back is measurement information or an overall pass-fail result, and we'll show that today. With EIP communication, both explicit and implicit messaging is supported. There's trade-offs for both of those. Implicit messaging is generally easier to set up, but it takes up more network traffic. Explicit messaging requires a little more ladder diagram code, but it doesn't hog your network as much. And again, we'll show both of those here in our demo. And LMI facilitates the setup of this communication by providing an EDS, or electronic data sheet. This is pretty typical for network devices that want to communicate with a PLC. The EDS file allows the PLC to recognize your machine vision system as a network device, and defines the register mapping and the controller tags so that you don't have to do that yourself. It really makes, as you'll see, it really makes the setup easy. So what I will be demonstrating, and again, I apologize, this isn't the sexiest of demos. We're going to show implicit messaging and explicit messaging, sending bits back and forth, data back and forth between the PLC and the machine vision system. And I'll reference our extensive user manual here. That's a good place to go for all of this information. And we also, LMI offers some sample PLC code if you don't want to create everything from scratch, although I think you'll see creating things from scratch is not difficult at all. All right, let's get started with the demo. I'm going to switch over to my PC. Great, so let me launch our Studio 5000 software. This is a Rockwell software that's going to allow me to connect to the PLC and configure the program in the PLC. And like we said, for implicit messaging, I'm just going to start with a new project. Give it a name, specify my I/O modules, and let that get started booting up. The machine vision system that we're using here today is a Gocator 3210. It's one of our snapshot models. And what we're looking at is just a plate with holes in it. We have a very basic program measuring the radius of one of those holes. And again, if you've seen our other webinars, you know that LMI is capable of some pretty amazing scans and has very advanced inspection and measurement software. We're not showing that today. So just understand all we're doing is using the job file to measure a radius on the part. We have two jobs in our Gocator, job labeled 1 and job labeled 2. That's what we're going to switch back and forth between. They have subtle changes. One measures a small hole, so you'll get to see that difference in the course of the demo. All right, let's switch back to our Studio 5000 software. You'll see we have an empty program here. I can show our controller tags. These are the default controller tags. There's nothing in here related to a vision system. What we're going to do is add our Gocator as an Ethernet module. And in order to do that, we need to have installed the EDS file. And I'll show you where to go for that. In our Gocator, if we go to the Output tab, and I've already selected our Ethernet IP protocol here. Down at the bottom, though, is Download EDS file. And when we do that, and we're connected to the internet, a zipped up EIP file gets downloaded. We can extract that, move that into our downloads folder. And now within our Studio 5000 software, our EDS installation wizard can reference that EDS file. So I've already gone through this, but I'll show kind of what the basic steps are for setting that up. You just walk through this wizard, register an EDS file, and point it to the file we just downloaded. There it is. And what that does is it'll allow us to add over here a new module that's recognized as a Gocator. We'll filter by vendor, LMI Technologies. There's one EDS file and one device that works with all of our vision systems. And so when we create that, we have to set a couple of parameters. We have to give it a name. We can call it G3210 or whatever you want, and specify the network IP address. And then if we want, we can change the request packet interval. With implicit messaging, this is how frequently registers get updated, how frequently data gets sent back and forth between the PLC and your machine vision system. The default value, 10 milliseconds, is fine. That means data is going to get updated 100 times a second very fast. So we'll hit OK and close out of that, and you'll see down under our Ethernet modules, we have our Gocator added, and that has also added a bunch of these controller tags. And this is really the power and the benefit of having that EDS file is you don't need to specify what address and what name your run state is at. The EDS file does that automatically. All right, so that's really all we have to do here with setting up our Ethernet module, setting up the controller tags. Let's go ahead and download this to our PLC. Here's our actual PLC at this IP address. We can download, go into run mode, and hopefully those controller tags will start to get updated. And as I mentioned, on the Gocator side, we're just measuring a whole radius and going to communicate that value to our PLC. Let's set the PLC into run mode, and now it's running, and I can already tell that data is being passed back and forth every 10 milliseconds. We've got this run state value updated. It's a 1. If it was a 0, that would mean our sensor is stopped. And we should also, as we scroll down through these values, we should also see our measurement. Right now, we're only taking a single measurement. Here it is. It's 20,000 microns. On the Gocator, it's displayed in millimeters, but that value is the same on both systems. So again, not too flashy. We're just passing that value back and forth, but that's communication using Ethernet IP implicit messaging. We're also passing a decision value. So typically, you might use a machine vision system to decide if a part is good or bad. We have a tolerance here that we can set. By default, the tolerance is 0 to 0. We can set this from 19 to 21, and what that'll do is it'll change this from a failure to a pass. So back on our PLC, when we look at the decision value, that's going to be over here. Right now it's 0. 2 means invalid because we're not having any more than one decision right now. We're just taking a single measurement. But if we change that decision range, you should see that change from a 0 to a 1. So let's change this. We can say 19 to 21. Now this turns green, and over in our PLC, we see this value is now a 1. So that's showing how to use implicit messaging to receive measurement information, pass-fail information from a machine vision system. Let's go ahead and send a command from our PLC to the machine vision system. And for that, we're going to use the other tags. Here, we're going to use our output tags. And we're going to send a command, and this is going to be our job file name. Now, to figure out what that command is, it's going to be some value. I want to reference our user manual because there's a lot of different commands you can send to start, stop the sensor, realign, or change the job, and those are going to have different command values. So in our Gocator, on our manage page, down here under support, we've got a link to our user manual. And that user manual is extensive. I think it's hundreds of pages. We have to drill down to get the exact information we want under integration, protocols, Ethernet IP, implicit messaging, assembly object, and then the command values are listed here. So we're going to load a job file. So we're going to want a value of 64 in this register. Let's switch over to our PLC, and we can first set the job file. So right now on our Gocator, we have job 1. And let's change that to job 2. So we'll just put in 2.jo. And then when we set this value to 64, that should initiate the job change. Because we're using implicit messaging, that data is constantly being updated. The PLC is constantly sending that command over. When that command changes, you'll see a change on the machine vision system. We go back to the machine vision system. We have to refresh our view, but we should see job 2 listed over here. And if we look at our measurements, job 2 is a little bit different. Now, instead of measuring the big hole, we're measuring the small hole, getting a slightly different radius, a little over 5 millimeters. And if we go back to our PLC and look at those measurement values, we should see those in the input register on our PLC. Let's scroll down, and there it is, 5,000 microns. All right, so that's implicit messaging. Let's go ahead and demonstrate explicit messaging. And for that, I'm going to use the sample code that LMI provides with our utilities package. So when you download our utilities package, you get a bunch of things. You get our emulator and our accelerator. You also get an integration folder with some sample code. So I'm going to extract that and load it into our Studio 5000 software. This was developed for another controller, so I need to update the controller. That's fine. And then I'm also going to re-add that Ethernet module to our list here, just like we did before with implicit messaging, so that I can reference that in the explicit messaging code. What this program, the sample program, is going to do is give me some rungs of ladder logic that'll let me easily demonstrate explicit messaging. We're not going to save our old program. So here we are. If we look at our main program, we can see that there's a few rungs already programmed in. What we're going to care about is the explicit messaging. And all that includes is 2 rungs of ladder diagram code with a get instruction and a set instruction. The get instruction wants to pull out the serial number, and the set instruction is going to send a command. But in order to set these up correctly, I've got to have the right Ethernet module. So let me add that just like we did it before. This is taking advantage of our EDS file. So now within this message instruction, I'm going to reference my Gocator. And what this is going to do is it's going to, when I execute this rung, it's going to try to pull out the serial number from my Gocator and put it in this destination element retrieved SN. And with my set instruction, we're going to send a command over. What I'm going to demonstrate is starting and stopping the sensor. We'll do that here in a minute. But I do need to set the right network path. So that's it. Now I can download this program to my PLC, overwrite the implicit messaging project that we created a few minutes ago. And we'll put it back into run mode after the program is downloaded. All right, and so let's look at our controller tags. Again, this is what the EDS file makes possible. We've got our Gocator input and output, but we also have these variables that have been created with the sample code, specifically this retrieved serial number. And the serial number here is 40278, and that is not the serial number of our Gocator. It's the serial number of the Gocator when this program was originally developed. The serial number of our Gocator is 49157. So that's what we should be seeing in our controller tags. The reason we don't see that is we haven't executed the get instruction. So our PLC is running. We're first going to go to the main routine and specify that we want to run the explicit messaging routine. We'll toggle that bit. And then under explicit messaging, we'll toggle this bit here to execute our get instruction. And once we do that, hopefully our controller tags will see an updated serial number. And that command happens once. Unlike with implicit messaging, it doesn't constantly happen hundreds of times over and over again. All right, so that's using explicit messaging to get something from your machine vision system. Let's use the set instruction to turn our sensor into run mode and then to take it out of run mode. And to do that, we're going to use over here this set instruction with a command byte in this source element. And here's where that value is going to go. Let's wait for that to expand. I am going to reference the help file, again, just like we did before, to figure out what commands I want to send, what values I need to put into that register. So before, we were looking at our implicit messaging documentation. Now we're looking at explicit messaging, assembly object, command assembly, and the values here are a little different than before, where we used 64 before to load a job. Now we would use 5. But I'm going to alternate between 1 and 0 to start my sensor and then stop my sensor. So let's go back to our PLC. Hopefully we can expand that. There we go. And so let's see if our sensor is running or not. Looks like right now it is not running. This is not red. I can force this into run mode, but I'm going to try to do that through the PLC. I'm going to set this to 1 and then execute that command by toggling this bit. Now, if I switch back to my vision system, you can see this button here is red. The system is running every 1 or 2 seconds. It's acquiring a new image and updating my data. And to finish out the demo, I'll stop my sensor. So I'll change my command bit to 0 and rerun that single rung of ladder diagram code. And now when I switch back to my sensor, it is no longer in run mode. All right, so that was the demo. Again, to summarize, we showed implicit messaging and explicit messaging using commands from the PLC, receiving data back from the vision system. And I pointed out that LMI offers pretty extensive documentation of this in our user manual, as well as downloadable PLC sample code. And with that, I'll turn it over to Trevor for the Siemens and Profinet portion.
Awesome, thanks, Mike. All right, so I'm going to be taking the Siemens PLCs. I'm going to be showing a demo on it, and for that, we're going to be using the Profinet protocol instead of the EIP protocol. Very similar to the EDS file, they have a GSD file, which stands for a general station description, and does something very similar. It's used to allocate the memory for to the PLC for the Gocator. The difference is that it's not going to populate any tags for you, but I'll show you how you guys can make your own tags to access the memory locations. 2 notes for Profinet communication. One is that it's not supported in our revision A and B 2100 and 2300 sensors. This is a hardware limitation. That's why we came out with a revision D sensors. So any new sensor that you buy now will be supported by Profinet. And the second note is that Profinet communication is not supported with our computer-based applications. So the SDK, the emulator, and the accelerator. Again, I believe this is a hardware limitation. And it's also not supported with our GOMAX currently. Hopefully, in the future, it will be supported with our GOMAX. So it's very important if you guys need to accelerate the sensor. Profinet may not be the perfect solution for you. Okay, so for the demo, I'm going to be going through 32-bit alignment. And this is just the way that the registers are mapped. You can kind of see off to the right in that little photo, there's little registers, and it kind of tells you the byte indexes of those. Our other mode that you can operate in is our legacy alignment, which is a legacy version of our register mapping. So I'm just going to be focusing on 32-bit alignment for this demo, but they're pretty much the same other than just what bytes you're going to be accessing. So what we're going to do is we're going to add the GSD file so we know, so the PLC knows what sensor is. We're going to configure the PLC for the Gocator, and then we're going to start and stop, receive a measurement, change the job file just like we did in EIP. And then for any help documentation, We really only have the user manual at this point. So just like Mike, I'll show you kind of what that says, and it'll help us with the commands and such. But there isn't any additional program or extensive documentation. Hopefully in the future there will be. That I will share my screen. Okay. So with the same sensor, I'm going to use TIA Portal. And I already have a project open just because of my PLC tags. I've already specified what they are. So you guys don't have to watch me put them in one by one. But if we look at our devices and networks, we just have our PLC at the moment and nothing else. So we need to add in our GSD file. And for that, we're going to go to the sensor and we're going to go to the output page. And instead of Ethernet IP, we're going to switch over to Profinet. Now I'm going to save this job so that the output will be Profinet when I load it back. And at this point, I can download the GSD file. And while I'm here, I'm also going to load in job 1. And I'm also going to switch this to Profinet. I'm going to save that. Awesome. If I go back to 2, we should still have Profinet. Great. Okay. So let's go into our downloads and extract the GSD file. Awesome. We have a little icon and then the actual GSD. And then going into TIA Portal, up here on the options section, there's a manage general station description files. And we can specify where that is. So for me, I just downloaded it. That was GSD1. That's okay. And I'm going to check it and start the installation. Hopefully it should be semi-quick. All right. And if you guys do have your sensor accelerated, you will not see the Profinet as a drop-down menu. So that's how you know that it's not supported. There isn't going to be any error or anything. Let me exit out of this. Maybe it'll quicken it. Okay, awesome. So going back to the devices and networks, we can now add in the sensor by going to other field devices, Profinet IO, sensors, and then LMI sensors, and then dragging and dropping the Gocator in. Great. Now we're going to connect this to the PLC. And by doing so, we will now assign the memory structure to the PLC. And this is what it looks like. So we have a control module, runtime variables, state, and then this is a stamp, and this is measurements. Okay. Now we need to specify that this is going to be 1.15 as the IP address. And also at the bottom here, we have a Profinet device name of Gocator-LMI. If I go back to the sensor, our device name is already Gocator-LMI, so hopefully we won't have to assign the name here. But if it has no name assigned, you will have to assign the name for communication to work properly, which I'll show you how to do that. And at this stage, I can download to the PLC, which you'll need to search for it, select it, and load. Okay. Load it. Of course, it's going to take some time. And finish. All right, so at this point, should be able to go online. And we're getting all green check marks, which is great. If I go over here, we're getting all green check marks, which is great. But if you do not get all green check marks, if you're getting red X's at all, it might be because the Profinet name was not assigned. And in that case, we can go down to our ungrouped devices here, which is where the sensor lies. And this little green check mark icon, it'll be like a little wrench, a red wrench. And you have to double click that. And if you do, pops open this. And underneath this functions, there's a assign Profinet device name. And in that case, we can update the list here. And Gocator LMI was already populated because it's my only device on the network. But if you had something else, it just can drop down and find that. And then it'll find it. And at this point, it tells me status is OK. If it were not to be OK, I could select it and assign the name. And hopefully that should resolve any communication issues or connection issues that you have with the sensor. OK. So I've set up a watch table as well. So we can now control the sensor and view any of the registers that we'd like to. So currently, I am viewing the command register and the arguments registers down here. Maybe I can move that up. All right, and we can look at the state module to see if it's running. We can look at the job name and then just measurement 0 in the decision. So at this point, sensor should not be running at all, which it's not. And if I start the sensor up, we go back to TIA portal, and we put the little spy glasses on, we can see that the state running is a 1. If we go back to the sensor and stop it, you should see that now it is 0. And we can do this also via command. And we'll go to our documentation. So we had a tunnel deep for EIP. Oops. But not very deep for Profinet, as it's just one page. And this goes over the legacy registers, but we want 32-bit alignment. So here it is. And this is our control module, which takes care of any control that you would like to do with the sensor. So byte index is 0 for this in this case, which is my command register. I have that set up already. And these are my commands that I can do. So let's try starting the sensor by using a 1. So I'm going to modify the value of the register. I'm going to click this little lightning icon to update the register. And you see this updated as well. And now the sensor should be running. Great, it is. Okay, and if I want to stop the sensor, I'm going to put a 0 in there. So it's running currently. Let's put a 0 in there. And let's modify the register. And at this case, this register is just modified. And now we're stopped. Okay, so I put it in running state again. We can also see the measurement that is there. Job 2 is selected, so we have the small hole with a radius of 5 millimeters. If we change this, maybe the min to be 5 and the max to be 6, it should turn green. And now we can see this decision just changed to 1. So that's working great. Now let's change the job so we can change this value. For that, I'm going to use the arguments here. And I guess I can show you why. So in this control module, we have these buffers, and then there's these command parameters. And for the command parameters, they will specify the job name, which explains it here. And then I will also use a command of 5 to load the job name in. Very similar to loading runtime variables if you guys are doing that as well. In this case, we're just going to load the job. So I have character format here. I'm just going to load job 1. Okay. These both are checked, so I should be able to modify both of them at the same time and switch the job. This is also the job name, so we can hopefully see this change, which we did. Great. And now if we refresh, we can see that we have job number 1 loaded, and now we're measuring a different hole, and our decision is red. So our decision is 0, and we have 20 millimeter radius, which looks to be about correct. And I believe that is it for the Profinet communication. If I missed anything, let me know. I can go over it. I can stop sharing now. And with that, is there any questions?
Yes, so I do see there's a couple of questions from Martin. One is he's asking if our single point sensors, if there's going to be a Profinet communication supported in the future. I could probably take that one. I'm not entirely sure. I have to check in with our software engineers. We have a big release coming. I'm not entirely sure if that's going to be supported. Michael, maybe you know better.
I've not heard of that being supported.
Okay. All right. Now the second question is something we could probably definitely answer today. Is it possible to communicate with sensor via Profinet and at the same time with SDK?
Yes. Definitely. Yep. Definitely. Yeah. So I guess you can communicate with the Gocator protocol with any single output protocol selected, which is the SDK uses the Gocator protocol. So Ethernet IP, Profinet, doesn't matter.
Yeah, for those people that are familiar with our software, in the output tab, we allow you to select the protocol, and one of those options is the Gocator protocol, which is what the SDK uses. That is always enabled. Whether you're using Ethernet IP or any other protocol, you always get the Gocator protocol. So you're always able to communicate using the SDK, but then you get one additional protocol. So you can't, for example, communicate to an Allen-Bradley PLC and a Siemens PLC at the same time. We've never had that request, but you certainly can do what Martin asked about with communicating with SDK and the Siemens PLC.
Excellent. Martin, hopefully that answers your question there. I see you have a few more details in there just around with C# net applications, and in a first step C# application would mainly use restore measurement data. I think there's just a couple of details in there. Hopefully that answered your question. If not, please reach out to any of us, training@lmi3d.com. Happy to answer any of those questions. Excellent. So just give it another minute or two. Question number 1 is, Martin, I'll have to check into our software engineers, see if that is something that is in the works. We have a big software release coming. I'll have to get back to you on that one. Yeah, I'll have to take that one away. So maybe just to allow for another minute, if anyone else has any questions, Michael or Trevor, do you have any closing remarks for today?
No, I want to thank everybody for attending. Yeah, we hope you got a lot out of this. As Aaron reminded you, this session is recorded, and we have pretty extensive documentation. So if you don't remember everything that we covered today, feel free to view the recording or go through our documentation.
Right. Yep. And if you have any further questions, just reach out to us.
Absolutely. Michael, Trevor, thank you so much for taking the time to go over this with us today. And thank you everyone at home for joining in. Have a great day.